Welcome back. In our last video, we looked at multiplying rational expressions. In this video, we're going to look at dividing rational expressions. So let's remember back to multiplying. We had a fraction multiplied by a fraction. I was able to just draw that line through and extend it and just multiply the numerators and multiply the denominators. Division is a little bit trickier. If I have a over b divided by c over d, division by a fraction is the same thing as multiplying by the reciprocal. So a over b divided by c over d becomes a over b times the reciprocal, which is d over c. Once I've done that, I can just extend the division. So multiplication and division are related and very similar, but we have this extra first step when we're looking at division. Let's start off with a simple example here. So I have 18xy cubed divided by 7a squared b squared divided by 12x squared y divided by 35a squared b. Step one is we're going to find the reciprocal of the second term. So that means this term is going to get flipped. So I have 18xy cubed divided by 7a squared b squared. Now, instead of division, I'm going to change it to multiplication, and I'm going to flip this. So it will be 35a squared b over 12x squared y. This just gets extended into one big multiplication with multiplication in the top and the bottom. I'm going to group like things, so I have 18 times 35 times x times y cubed times a squared times b divided by 7 times 12. I have an x squared here, I have a y, I have an a squared, and I have a b squared. All right, so the 7 can cancel with a 7 from the 35 and leave me with a 5. 6 can cancel from each of these, leaving me with a 3 in the numerator and a 2 in the denominator. The x in the numerator and the x squared in the denominator will become just an x in the denominator. Y cubed in the numerator and y in the denominator will leave me with y squared in the numerator. A squared in the numerator, a squared in the denominator cancel. B in the numerator and b squared in the denominator will become b. So now I'm left in the numerator with 3 times 5, which is 15, y squared, divided by 2xb squared. That is my fully simplified expression. Looking at a slightly more challenging problem, in this case, I also want to state the domain. So we'll come back to that in just a minute, but to start, I need to fully factor all of my terms. My first step is going to be to fully factor. Before I flip this, because I need to find the domain, I need to fully factor. My domain restrictions happen when I'm dividing by 0. So if at any point a number is in the denominator of something, we have a domain restriction. So to fully factor, x squared minus 16 becomes x plus 4 times x minus 4. 12y plus 36, I can factor out a 12, and I'm left with y plus 3, divided by x squared minus 12x plus 32 is going to be x minus 8 times x minus 4. Y squared minus 3y minus 18 will give me y minus 6 times y plus 3. Domain restrictions. I have y plus 3 cannot be equal to 0, so y cannot be equal to negative 3. I also over here have y plus 3 can't be equal to 0, but I have y plus 6 cannot be equal to 0. So that is y cannot be equal to positive, sorry, this is y minus 6, so y cannot be equal to positive 6. So these are some domain restrictions. Now, when I go from division, my next step is that I need to flip this. So I have x plus 4 times x minus 4 divided by 12 times y plus 3 times y minus 6 times y plus 3 divided by x minus 8 times x minus 4. I now have another step where I have things in the denominator that I haven't considered yet. Because these are now in the denominator, x minus 8 cannot be equal to 0, giving me x cannot be equal to 8. And x minus 4 cannot be equal to 0, so x cannot be equal to 4. So I have two new domain restrictions, and there's no new domain restrictions over here. Multiplication now, so I can just extend that, and I can cancel like terms. So there's no x plus 4 in the denominator, x minus 4 in the numerator and the denominator, y plus 3 in the numerator and denominator. So I am left with x plus 4 times y minus 6 over 12 times x minus 8. And this is my fully simplified rational expression. With all of these domain restrictions. So remember, domain restrictions came from my initial and then my next step as well. We will only add domain restrictions. You will never remove domain restrictions. Looking at this problem, this is just another way of looking at division. I have a plus 4, or a plus b divided by 4, divided by a squared plus b squared over 4. This big division is really just meaning I have a plus b over 4 divided by a squared plus b squared divided by 4. So now this is going to become a plus b divided by 4 times 4 divided by a squared plus b squared. That can become one big multiplication, or one big division with multiplication in the numerator and denominator. The 4's are in common. A squared plus b squared cannot be factored, so this just becomes a plus b divided by a squared plus b squared. Really, really important. We can only cancel out entire factors. A plus b divided by a squared plus b squared cannot be simplified because a squared plus b squared cannot be factored. We can only cancel out entire factors. We can't cancel out terms if there's any addition. But once we get to that point, we stop and we're done.